In this video, we will write a basic Express JavaScript project, then build a Docker image out of it and deploy this image to Compute Engine in Google Cloud. This is a diagram with the components we have in our Google Cloud deployment. So we have a Compute Engine virtual machine running our Express server in a Docker container, and then we will expose this server to the internet using a global load balancer. This is a reverse proxy that will do the SSL termination. So the traffic coming from the internet into the load balancer is with HTTPS protocol, and then from the load balancer to our server, it will be HTTP. The load balancer will generate an SSL certificate for our domain, so we don't need to purchase an additional certificate. Also, there are other performance benefits for using this reverse proxy. For example, it is very efficient at serving static resources such as images, JavaScript files, CSS. And also, if we have a deployment with several servers, it will distribute traffic between them and also detect when one of the instances is down. Because the load balancer cannot send traffic directly to a Compute Engine VM, we will need to add this VM either to a network entity group or NEG or to an instance group. We will try both options and then discuss the pros and cons of each. If you want to follow along with the video, you will need a Google Cloud project with billing enabled and also a DNS domain that you can add entries to. All the source code, URLs, and commands we use will be linked in the video description below. And if you want to support the channel, please like this video or consider subscribing. There are a lot of videos related to Google Cloud, to backend engineering, and other topics. Thank you. We will start by writing the code to our project from scratch. So first we need to create a new directory in here. Let's call it Express GCE. And then we will just run npm init inside. Yes, the defaults look good. Everything looks good. I'm going to use IntelliJ for writing the code, but you can use the editor or IDE that you are comfortable with. So we can see that our project right now only has a package.json. We'll need to create the index JavaScript file, which is our main file, and also install a few dependencies. So in here, we will install the Express with npm I express in the terminal. We can see it was just added. And also, I will install the node.mon dependency. It helps with development. This one I did npm I for install and then -- save -dev to add it as a dev dependency. So now we just need to add the index.js file. We add it as a JavaScript file index like that. And also we need to add scripts to package.json. We will do, let's call this one start. So this one will be node and then index.js. And we will also do a dev script. This one will use a node.mon and then index.js. So node.mon, in case you haven't used it, it restarts the server every time we make a change in the directory. Next, we can write our index.js file. So in here, just add the normal basic Express scaffolding. So we require Express. Then we start the server. We do const app equals Express. Then app listen. Actually, let's save the port inside a variable. We'll configure it later. For now, let's do port 3000. So port, and then a lambda function in here. So we'll just do console log server is starting on port, and then the port number. And we're going to add a basic hello world endpoint with the get. You'll have the Lambda function with request and response. So we just send back response hello world like this. So now in the terminal, if we just do node run dev, npm run dev, we can see the server started on port 3000, and we can try it out. Let's see. Localhost 3000, and we can see hello world, and that the server is starting on port 3000. We can make it a bit more interesting. Let's say we want to take the name of the user making the request and return it in the response. So this will be a query param. So we will have it inside request.query name, and if it's not provided, we'll just use guest. So in here, instead of hello world, we will return their name. In here, we need to do the string interpolation with backticks. So we just do name, and now we see that when we save the file, the server has restarted, and we can try it out. So if we just provide in here name equals Vlad, it will change hello Vlad, and if we remove it, it will say hello guest. And finally, we want to make this project a bit more production ready. We will add logging using the Winston library, and also make the port number that the server is running on configurable. So the port can be configured using an environment variable. The reason why we are doing this is because when we deploy it to Compute Engine, we will want our server to run on port 80. So in here, we will use process.env.port, and if it's not provided, then it will default to port 3000. And the other thing we wanted to do is just log using the Winston library. So if we just search for npm Winston, there's a quick start in here on how to add it. So we need to install it with npm. So in the new terminal window, I just do npm I Winston. Yeah, the server has restarted, and now from the quick starts, actually, I want setup that does interpolation. So if we search for interpolation in here, there's the starter code that we can use. So in here, yeah, we need to move the import higher, like that. And now instead of console log, we can use this logger object. So it'll be logger, and the level will be info. They have several level warnings, error, and so on. So now it supports with the %s for string interpolation. And also we can log in here the request we received. So we can do receive the request for, and then the name. So now we can see that the format has changed to this format from Winston. This is important because in Compute Engine we will use a logging agent, and this agent will look for lines in the standard output with the specific formats, and the Winston format is captured, and then it will end up in a stack driver, which is what we want. So now if we try the other log line, let's say name equals Vlad, we can see that logged the request we received as well. The next step will be Dockerizing our project. So we can start by adding the Docker file. We just add a plain text file called Docker file. And we need to choose a base image from which we will build on. So if we go to Docker Hub and search for the Node image, we will see that there are a bunch of different versions. I usually use the slim version because it results in a smaller Docker image. And unless you need the command line tools from Linux, then this one will do. So we can use this one, 20-slim. So we build on this image. We will do from node 20-slim. Then we set up a working directory. Let's call this one app. And so the files that we need in our project are index.js, package.json, and packagelog.json. So we could just like copy them individually, or I will choose to copy everything in the current directory to the app directory. And then we will just exclude the .idea and node modules using the docker ignore file. I'm doing this method because if you have a more complex project with multiple directories with the source files in here, they will all be copied, so it's more extensible. But also the problem is that you need to exclude your IDE index files. If you're using a different IDE like VS Code, you will need to exclude the symbol objects as well. And also node modules, we don't want to copy them in the Docker image because there are too many files and it will take forever. But instead, we will run npm install after we copy the package.json. So in here, after we copied all the files, we run npm install. And then the entry point of our project will just be npm and then start. So if we go back to package.json, we see that we added this start script that is not using node monitor. So yeah, and now what we need to do is also add a new file in here called docker ignore. And in here we want to blacklist .idea. If you're using Visual Studio Code or other IDEs, again, you should add that directory as well. And also node modules we don't want to copy in the Docker image. And yeah, now it looks good. We can try it out. So if we do in here a docker build tag, let's call this one express GCE, and then dot for the current directory. This should build our image. Yeah, we can see it tagged it with express GCE. So if we do docker images at the top, it will list the image we just built 6 seconds ago. So now we can just run it with docker run express -GCE, and we see the log line that it says server is starting on port 3000, which is very good. Actually, the Control-C for killing the Docker image doesn't work in IntelliJ, so I'll just close the terminal. Now we will move to the Google Cloud side of our video. So we'll just open the console.cloud.google.com to go to the Google Cloud console. And I will create a new project just to make sure I go through all the steps. We can leave the name in place. What is important is this unique project ID. So we can just create it. And once it's created, we switch to this project. We do select project. Or you can also switch from this drop-down menu. And we also have to make sure billing is enabled. So if we search for account billing, I think, billing accounts, Okay, so now at the bottom in account management, we should see this one. This is the project we just created, 68464 solar attic, and this is good. It means we are good to go. Now we will enable artifact registry, which is the place where we will push our Docker image. So if we search in the search bar for artifact registry, and we click enable. Okay, now we need to add a repository in here, Docker. Let's just call this one Docker. Standard region. We can select a region in here, let's say US West 4, because it's closer to me. You can select a better region for you. If you deploy images across multiple data centers, maybe multi-region is better for you. So now we need to follow these setup instructions. From here, just run this command in our terminal. This looks good. And now we need to tag our Docker image, which was, I think, Express GCE. We need to tag it to this path from here with this name that we copied from here. So we will do Docker tag and then Express GCE. So we paste that name from there, and we add Express GCE at the end. And now we just push the image with the new tag. So we will do Docker push and then the new name of the image. Okay. So if we go back to artifact registry, we see our image in here, and this is the latest version. We also don't have to push the image from localhost with Docker push. We can use cloud build. I have another video for that on the channel. There will be a card at the top if you are curious. Next, we will deploy this Docker image as a compute engine container. But first, we need to reserve two static IPs, one internal IP and another one external. So the external IP is the one that the load balancer will use. If we go back to our diagram, so the static public IP will be used by the global load balancer, and the internal static IP will be used by the network entity group. So for this, in the search bar, we will go to VPC networks. VPC stands for Virtual Private Cloud. We can continue. Yeah, we need to enable Compute Engine first because it's a new project. I skipped ahead a couple of minutes while Compute Engine was enabled, but now we can go to IP addresses and VPC networks. So in here, we reserve an internal static IP. Let's just call this one internal IP. Network default, subnetworks. Yeah, we need to choose a region for our deployment. I will use US West 4, but we need to keep this in mind. We need to have our VM and the internal static IP in the same region. Let's see, we need to find it. US East. Yeah, I think they're alphabetical. US West 4. Of course, for you, you can pick one that is closer to you geographically. This looks good. Okay, and we also reserve an external static IP. Let's call this one external IP. Region, yeah, we do the same region again. We don't attach it, and there will be this warning sign, static IP is not attached or built at a higher rate, but it is not a problem because we will attach it shortly. So we just reserve it. And we can see both IPs in here. Now we can create the compute engine VM that will run our Docker image. I'm going to open a new tab with the Google Cloud Console. So in here we need to go to Compute Engine and create a new instance. The name does not matter, but we need to select the region in which we reserved our internal IP. In my case is US West 4. And in here we will select the smallest instance. We will see that the price gets updated. And for the container, we need to deploy our Docker image we just pushed to artifact registry. So we can open a new tab with the Cloud Console and go to artifact registry. So in here, we select our image and also click on the latest image, and we can copy the SHA of the image. There's this shortcut in here. So we just fill it in a container image. You will see some examples on the internet where they use express GCE and then colon latest. I prefer to specify the complete SHA of the image being processed because it's more explicit what image is being run. The compute engine VMs will pick up the new image every time they restart. So if you had a VM running for a few months, if the version says latest, it will be unclear what is the exact image that is being used. So in here, this looks good. For a restart policy, we will do always. What this will do is that every time our server crashes because of failure or a exception, the Docker process will start it back up. If we had a batch job in here, we would have to use never or on failure, and that will make sure that once our batch job finishes executing, then it will not be rerun. But in our case, for long-running services, we need to select always. And let's see, environment variables. We will configure the port of our server to the default HTTP port, which is 80. We can do this one because we made it configurable with the environment variable. And also we will set node env to production. This will make the Express server a bit more efficient. Okay, this looks good. Now we need to enable the HTTP traffic. As we recall from the diagram, the load balancer will receive HTTPS traffic and then send HTTP traffic to our VM by using the NEG or instance group. And now in advanced options, inside networking, we need to select the default image, and for the primary internal address, in here we need to use the internal IP we reserved. For external, ephemeral is fine because the traffic will be sent from the load balancer. And one more thing that we need to do is to turn on the logging agent. This agent will capture logs from the standard output and send them to stack driver logging, where they will be archived. We can search them and so on. So if we search on Google for GCP, let's say container OS logging agent, we will see here instructions on how to turn on the logging agent. There's a warning in here that they are deprecating one legacy logging agent and turning on another one. So for turning on the new one, we need to add these two fields to the metadata. So this one, we scroll down and there will be a section metadata. So in here we can add item. This one is true. And we add the second one as well. I will link this page in a video description below. This one with Fluent Bit. Yeah, it looks like the web UI for Compute Engine has crashed. And I tried several times with different browsers and it keeps crashing. I don't know, it's very strange. But this is a good opportunity to talk about the other option we have for enabling cloud logging. So actually, our logging library, Winston, we can add a transport in here that will send logs to Google Cloud. So if we search for, let's say, GCP Winston logger, I will link this one as well. So we just need to add this logging Winston in here, and we need to install this dependency to our project. So we can install it with npm I. Let's see in here. Yeah, we will do in a terminal npm install I for install, and then the name of the dependency. Okay. So now we created this logger. This the transport, not the logger. We already have the logger from Winston. And one thing we need to be careful with in here is that we need to add the transport only when we are running in production. So I will, because we don't want to send the logs from our local host to production, that will pollute the logs, and it will be unclear when we are investigating issues which logs came from localhost and which logs came from the cloud. For this, I will use the Node_env. So when it is set to production, then it will add this transport. But you can do a different environment variable, like something like cloud environment. Actually, yeah, let's do that one to separate Node.env from logging. So in here we will do the spread operator. So if it's if process.env let's say cloud env equals, let's say, GCP, then we add the logging Winston. Otherwise we don't add anything. Let's see what is wrong. Yeah, this looks good. So yeah, the server has started again. So now we need to build the image again. So we will just build it straight up with the correct tag. We will do docker build -t and then the tag with the full name in the artifact registry, and then dot for current directory. Okay, and now we can push this image we just built. So we do docker push and the name of the image we just built. We will see that some layers already exist. So we only need to push a part of the image. And now if we go back to artifact registry, we should see that it pushed the second image that was created just now. Okay, so now we can try again to create our VM in Compute Engine. So in here, I reloaded that page. After it crashed, it asked me if they wanted to reload, but we can start doing it from scratch. So in Compute Engine, we do create instance. We need to select the region where we have the internal IP reserved. In here, we select the type of instance we want. For container, we will deploy the latest one. So we copy the image with the SHA like this. Restart policy always. So environment variables, the port will be 80. Node env, it will be production. And also the new variable that we added, cloud env, it will be GCP. Cloud env GCP. This looks good. We enable HTTP traffic. And for networking, in network interfaces, we go to primary internal IP address, and we select internal IP. And yeah, this should be good. Now we can just create it. Okay, so after we wait for like a couple of minutes for the VM to pull our Docker image and start it, we should be able to see the log coming in with server has started on port 80. Yeah, we can see it right here, this line. So we can see that our server is running, and also it is sending logs to Stackdriver. The next step in our deployment is creating the network entity group or the instance group. We will create both and discuss the differences between the two. So the network entity group, or NEG, is simply a list of internal IPs in our network. So we can have different types of servers in there, and it doesn't do anything. It just maintains that list, and then when a global load balancer receives a request, it looks in that list for the instances that are healthy, and then it sends a request to one of them. The instance groups are more managed. They have the same type of servers, and also they can scale up and down, meaning like if our servers are overloaded, they can add new instances, or they can if there's very little traffic, it will remove some instances, and so on. It also has rollout deploys. Let's say we have 5 servers and we want to deploy a new version of our Docker image, then it will do a rolling restart of our servers. We can configure if we want to deploy one server at a time, and so on. NEG doesn't do any of that. It just contains a list of IPs. And if we want to deploy new images, we need to do that ourselves. However, I found the instance group is it's a bit harder to manage. Like if we want to deploy a new image, then we need to create a new version and then set up that one. So I would say for a very small deployment with 1 or 2 servers, you should use an NEG. And for a more complex one, if you have 5, 10, a dozen more, maybe the instance group is the better choice. We will create the network entity group first. So for this, we just go to Compute Engine, and here in the left menu, under Settings, there will be a link for network entity groups. In here, yeah, we create a new one. Let's call this one Express-NEG. We keep it to zonal. And for network, it will be default. And for subnetwork, we need to select the same region where we created our VM, and also our where we reserved our internal static IP. In my case, it's US West 4. So this UI is not great. We'll just need to scroll down until we find our region. Here we go. Okay, zone doesn't matter. It's fine. Port, it will be port 80, the default HTTP port. We can create it. And now we can just add a network endpoint. So NEG, as we discussed earlier, just contains a list of IPs of the servers in our group. In here, we select instance 1. And for the IP address, we need to enter the static IP of our instance, the internal IP, so it will be this one. This is the reason why we reserved an internal static IP, because although when we stop and restart VMs, most of the times they will start using the same IP. It's not actually a guarantee. It's safer just to reserve one. And also it doesn't have any additional cost reserving internal IPs. External IPs have a bit of a cost, but that one we cannot avoid. And we see our IP was added. Now we will also see how we can create an instance group. Instance group is the alternative to NEG. So for this, we first need to create an instance template. In a compute engine under VM instances, there should be instance template. So here we give it a name. So every instance template would be associated with a specific Docker image. So if we want to update the Docker image in our instance group, we need to create a new template and apply it to our group. So that's why I usually version them. We can version them with V1, V2, V3, etc. Or it's also a good practice to use the first few characters of the SHA of our image. So it can be 949, for example. Actually, that's a bit better. Let's do SHA 949. Here we need to select the machine type we want for our servers in the instance group, and all the servers will have the same machine type. For container, we are going to deploy this, the older version of our Docker image, because I also want to show how we can update a version of an instance group. So in here, I think we had port 80. Then a node environment production. And I think we had cloud env GCP. Let me double check. Yeah, cloud env GCP. Like that. And I think we also enabled HTTP traffic. And now we don't need to, we can use ephemeral IPs. We don't need to reserve internal IPs. So yeah, everything looks good. Okay, so once it is created, we can create an instance group out of this template. Let's call this one Express Instance Group. For a single, here, yeah, we can select the same region, US West 4. And here, this is one of the features that instance group has that we cannot do with network entity group. We can turn on auto scaling, so and then select the criteria in which it will auto scale. So in here we start our group with one instance, and then if this instance CPU passes 60%, then the Google Cloud will add another instance, and so on until the load is adequate for our number of instances. Here we can set it to maximum of 2. It also supports health checkers, so if one instance doesn't respond, it will be restarted. Here, let's call this one TCP health checker. So there are multiple options in here. We can do an HTTP health checker or a TCP. TCP just checks if our server responds to port 80, if it accepts connection. We can also, for HTTP, it will actually send an HTTP request, and it can check if we get the expected response. In some scenarios, our server can start, but maybe it's trying to warm up some connections to caches, to databases, and the server is not yet ready. In that case, an HTTP health checker is better, but in our case, we will do TCP. Okay, this looks good. We can save it. Port mapper, no, this is fine. Okay. And yeah, for auto scaling, I set a maximum number of instances of 2. We need to set this number higher than the minimum number, because otherwise we will have problems when updating the version. Because when we want to deploy a new image, first it will add a new server to the instance group, and then once the new one is healthy, it will kill the old one. We can just click create. Okay, the instance group has been created. I had to skip over a couple of minutes. And if we go to VM instances, we will see that it created this new VM that is managed by the instance group we just created. And yeah, now we can see how we can update a new package for our instance group. Let's see in here. We can, we are in instance templates inside the template we created, and now we can do create similar. And in here, let's say we want to change the package, deploy the new one. So if we go to artifact registry, we will replace it with our newer package in here. So this one has CAE5, and in here for the name, we will name this new template CAE5. Let's do SHA CAE5. Okay, we created. Okay, and once it's created, we can go to instance groups and edit our instance group and replace the template with the new one. So we'll just do edit in here. And for instance template, we select the new one we just created. And it says here the template applies only for newly created VMs. After saving the settings, recreate existing VMs. So in here we do restart, replace, and yeah, we do restart. Okay. So we can see in here the instance is being restarted. Okay, we can see now that our VM is healthy. It took like a minute or so for the instance to be restarted. And if we go to VM instances, we can double check that our VM is running the correct image. And yeah, it says right here CAE563. And also we can double check in logging. We should see that log line. Yeah, we see here server is starting on port 80. And finally, the last step in our video will be creating the load balancer and testing everything end to end. Before we create the load balancer, I want to mention that load balancer do have a cost in GCP. So if we search for GCP pricing GLB, I will link it below as well. We will see that, let's search for load balancer. It's 2.5 cents per hour. So if we just multiply that by 24 hours in a day times, let's say, 30 days in a month, that will be $18. And we can have, that's for the first 5 rules, and then if we have additional rules, the cost will add up. Just keep this in mind. It does cost a little bit, but you can use it for multiple deployments inside the same project. With that being said, we can now create it. So in here, in one of the console tabs, if we just search in a bar for a load balancer, load balancing, it will be in network services. So in here, we just create a load balancer. We want an HTTP load balancer. There are multiple types of load balancers. We want the one from internet to our VMs. And this one will be the global load balancer. Let's call this one Express GLB for global load balancer. So the configuration will have 2 sections, one front end, which is the way our load balancer interfaces with the public internet, and the back end is how it interfaces with our network entity groups or our instance groups. So for the front end, let's call this one GLB-FE. And in here, we will want HTTPS because the load balancer will do the SSL termination. For the IP address, we need to, actually, it should list here the IP address we just created. It's strange, but we can create a new one, it's fine. So we'll just call this one GLB-IP, like this. Now for certificate, we can create a new certificate, and we will do the Google Managed Certificate. So let's call this one GLB certificate. And now, as I mentioned in the intro to this video, you will need a DNS domain that you can create subdomains to. In my case, I have my personal website domain, which is vladsave.com. So if we go back to load balancer, I will call this one express.vladsave.com, and I will add the entry shortly. We create this one. And yes, we want this redirection. This looks good, and yeah, if we let's actually add the IP to our DNS. So in a different tab, if we just look for IP addresses, we can see this one GLB IP is a reserved static IP. So this one we copy. I think the problem is that the global load balancer needs an IP that is not regional, and the one we reserved, it says here region US West 4. So we just copy this one, and in my DNS we will create a new record. The record we said is Express, and we add this IP. Okay. That one looks good. In backend, we will create a new backend service in here. Let's call this one NEG backend. So here we can see that we can select an instance group by default or a zonal network endpoint group, the one we have. There are other options if we want the load balancer to serve cloud functions or Cloud Run services, and so on. We will do the zonal NEG right now. So in here we select our NEG. Let's set a limit to the number of requests, let's say 40 per second. This looks good, and these are some optimizations that the load balancer can do. For example, it can cache static content like images, JavaScript files, CSS files, and so on. And we also need to select a health check for our NEG, and we will create one. Let's call this one load balancer health check. And again, we have the same options, TCP, HTTP. We will do TCP. If you don't understand why your health check is failing, you can turn on logs, but that will add a lot of logs and they do have a cost. For now, we'll just leave it off. We can save. And yeah, I think this looks good. So of course, if we wanted if we wanted to use our instance group, we will select in there the instance group. Okay, actually we can add a second backend that will end up in the instance group. Let's do that. Backend configuration. Create a backend service. Let's say instance group BE. So in here we just select our instance group, port numbers, it will be 80. Again, like this, 40. The same optimization, looks good, create. Yeah, we select the TCP health checker and we create it. So now for routing rules, so everything under IG, it will be in here under IG, it will end up in the instance group. Oh, and here we select our domain, express.vladsave.com. So express.vladsave.com /IG will end up to instance group, and everything without IG will end up on our NEG. Here it says the SSL certificate was created successfully. So now we just created. The load balancer was created. Also, one thing I want to mention is that we created an SSL, the load balancer created an SSL certificate that this one doesn't have any additional cost. It will be managed by Google Cloud, but it takes a while to provision. So if we enter the load balancer inside here in certificate, it will say status provisioning, and they say here that it might take 24 hours, which is a bit annoying, but in practice, maybe it takes like 10-20 minutes, and once this one says that it's valid, then we can test our website. Okay, the certificate is now active. It took something like 30 minutes in my case. So now we can test our website. It will be express.vladsave.com. Of course, for you, the domain will be different. And we can see it works. And the certificate is valid. It says in here it is issued by Google Trust Services LLC. We can try the query param. Let's call this one NEG. Hello NEG. And also we can also try the IG, the /IG path. So in here we can do name IG. Okay, so the problem is that the request is forwarded to our instance group, but the URL that is being sent contains the IG prefix, and our server can only respond to the root path, to the / path, So we will need to add a rewriting rule to our load balancer that rewrites /ig into / such that our server can respond. And we will go back to our load balancer in here. And we will edit it. And then in routing rules, so this rule ig, we need to add the prefix rewrite. And for this, we will need to do the advanced host and path rules. And the rule that we are rewriting is this one. So in here, there are some examples. And we need this one, rewrite URL host and path. So we need to add the route action. Yeah, we just copy it and we will transfer it to our configuration in here. Oh, it didn't copy all that. Actually, maybe we just copy all of it and we paste it in here. Okay, so we need obviously default service. We don't need all this stuff, just the route action. We don't need the weighted backend service or the host rewrite. So the path prefix will be just /. And this one need to be indented at the same level as service. So what this rule will do is whenever we send a request that starts with IG, it will remove the IG part from the URL and just send and forward the request to our instance group, but the URL will just start with /. So the IG part, the IG string will be removed. Yeah, this looks good. We just can do update. Okay, so now if we try again. Okay, so it takes a couple of minutes for the changes to propagate. But now we see that if we refresh, the request ends up in the instance group. We can make some more tests. Let's see, IG234. And if we go back to compute engine in instance group, we should see the IG234 request in the logs. Yeah, we see it right here. The last line, IG234, this one from here. So yeah, the request was routed correctly and the URL was rewritten. That's it for today. There are more videos related to Google Cloud if you want to continue watching. And if you run into any issues or you have questions, let me know in the comment section below. Thank you.